All right, so we're looking at now is that we're going to be looking at rational functions, so square root of something, cube root of something, and what we're going to be looking at is how to write those with just exponents. So instead of having, the square root of a, we're going to write it so it's a to some power, and that's what we're going to be putting these into. Okay. So rational exponents, it's whatever root you're taking it to is the denominator in the exponent, and then whatever the power is, or the power you're taking it to inside the radical or outside, that is what's on top. That's the numerator. Okay. So if we look here at 7, so we've got the cube root of 7. We could write that as 7, and then our exponent inside, we're taking 7 to what power? 1. And then what root is it? It's the third root. So we would take it, we're taking 7 to the 1/3 power. So now you can find this on your calculator. All you have to do is type in 7 caret 1 divided by 3 with the parentheses, and you can find the cube root of 7. So now we look at the second one. The second one, we have 6. That's our base. The power it's being taken to is 3, and the index, or the number that, or the root we're taking it, is 7. So it'd be 6 to the 3/7 power. Okay. And that's just the way that we would write these. And it helps us with these properties. So these properties agree with all exponents, and they even agree with your fractions. So if you have two things that have the same base, a, and you're multiplying them and they have different exponents. So like here we have 4 to the 1/4 times 4 to the 3/4. You would add the exponents together. 1/4 plus 3/4 is 1. So that would be 4 to the 1 power, or 4 to the first power. Now if you take a power and then take it to another power, you're multiplying those powers together. 7 to the third, or 7 cubed, and then that whole thing is taken to the 1/6 power, we would multiply it, which would be 7 to the 1/2, or the square root of 7. Okay. So if you take a power to a power, you're going to be multiplying. If you're taking two things with powers and multiplying them together, okay, you add them. So an exponent to an exponent, you multiply them. Now if you have two things being taken to the same power, you can break them apart. Okay. So if you have let's say 6 to the third. Now you go, oh, I can't do this. I don't know what 6 to the third is. You can break this up to 2 to the third times 3 to the third, because 2 times 3 is 6. So we can separate them, and this would be 8 times 27. And you're like, oh, I can do that one in my head. That's easier than trying to do 6 to the third. Okay. And so that's what we can do, is the exponent, kind of distributes to each variable inside. Right? So now here's a couple other properties that we have. If we have a base taken to a negative power, we put that base and that power in the denominator. So here we have 10 to the negative third. That would be 1 over 10 to the third. Okay. If we have 7 to the negative sixth, that would be 1 over 7/6. Okay. So the negative puts it in the denominator. Now if you're dividing two things with the same base, remember they have to have the same base. This is the same with the multiplying. They have to have the same base. If you're dividing them, all you have to do is subtract the exponents. So W7 over W2 would just be W to the 7 minus 2, which is W5. Okay. And if you have a fraction and you're taking it to a certain power, then you're just going to multiply the exponent into each part. Okay. So 3/8 to the fifth would be 3 to the fifth over 8 to the fifth. Okay. And then you can simplify it from there. All right, so simplifying this one. So the first thing we want to do is look, okay, we want to take this can be written as 25 cubed to the square root. Okay. We're going to start with that. We're not going to deal with the negative just yet. And so you can either square root it and then cube it, or you can cube it then square root it. Okay. In this case, let's take the square root first, and then we'll cube it. So we'll write it like this, cubed. So the square root of 25 is 5, and then we're going to cube 5, which would be 125. And now we're still taking it to the negative power, which means it goes into the denominator. So it'd be 1 over 125. And that would be our simplified form of this. Okay. So again, you could square root it and then cube it. You could have cubed it and then square root it, and it would have gotten you the same answer. And then you had this negative still floating around, which puts it in the denominator. So anytime you see a negative, you put it in the denominator. If it's already in the denominator, you put it into the numerator. It switches positions. So if you had 1 over a to the negative second, that is a squared. Okay. As you see, since it's a negative, it goes back up top. Okay. All right. Simplifying these. So if we look here, we're taking negative 4/7 to another power. So we go negative 4 over 7 and multiply it by 7. And that gets us negative 4. So we're taking x to the negative 4, which would be 1 over x4. All right, this one we're going to take the negative 2 and multiply it to both parts, which would be negative 12 times 2/3, which would be a negative 8. And we would have a negative 12 times a negative 1/6, which would be 2. So it looks like we have y2 and x to the negative 1/8, which would be y squared over 3x to the 8th. Okay? So again, it's just taking your time, making sure what you're doing. So your IRAT for this one, you're going to be simplifying these three, x4 times x2, or 6 to the 4th times 6 squared, so on and so forth. So use your properties that you learned, combine these, and simplify them down into its simplest form. Okay, we do not want negatives in the radical, so if you do have a negative in the radical, or in the exponent, you want to put it into the denominator, or move it from the denominator up to the numerator.